Okay, in this lesson we're going to discuss refraction of light and refractive index. These are the learner's outcome. Refraction. So what is actually refraction? Refraction is actually the bending of light when light goes into a different transparent medium. So this is one of the pictures that shows the refraction. Okay, light travels from here, it hits the glass, it actually bends or changes direction, and after that it actually comes out into the air and it changes direction again. So from the medium, this is air, into glass, it changes direction, and glass into air, it changes direction again. So light still travels in a straight line, okay, as shown, but it only changes direction when it enters into a different medium. So at this point it changes direction, at this point it changes direction again. So let's look at a video of a refraction. Okay, so right now you have all this beam of light. Let's see what will happen if we place some glass over it. So you see that the glass is over here, and right now you turn the glass, you notice that the light ray actually changes direction. It actually bends, and then after that it changes direction again, and from here it travels not straight, but it bends, and it bends again, it travels like this. Okay, so right now is that if the glass box is actually straight and the light ray travels straight on, the light ray actually doesn't get bent. Okay, so the reason for light changes direction only when it enters a new medium is because the speed of light changes in the medium. So anyway, the medium that we're talking about is all transparent. Anyway, speed of light is actually the greatest when it passes through unhindered, which means that in a vacuum. So speed of light in vacuum is known as 3 times 10 to the power 8 meters per second. And though air actually does really slow down the speed of light, but it's negligible for our discussion purpose. So generally for speed of light in air, we'll consider it to be roughly about 3 times 10 to the power 8 too. And of course, if it passes through hindered, so speed of light will actually slow down in the medium, but you will also slow down differently in different mediums. So speed of light in oil, and speed of light in water, speed of light in glass and plastic, they are all different. So how does changing speed of light in the medium leads to a change in the direction of light? Okay, so instead of using light, we'll consider the following situation, okay, to help us to understand. So a van that's going on from a smooth road to a rough ground at an angle, a van that's going on a rough ground to a smooth road at an angle, and a van going from a smooth road to a rough ground straight on. So this is what I meant for the first case. So you have this van that's going to travel like this from a smooth road to a rough ground. Okay, so this is the direction of the travel of the van. So what do you mean by angle? An angle means that if we compare with the surface of this surface, this is what we call a normal line. What I mean by angle is that it actually there's a difference between the normal line and the direction of travel. So this means angle. So right now, let's see what will happen. Of course, this is the wheel of the ambulance, and you find that this part of the wheel hits the rough ground first. So this part will travel very slowly. But this part of the wheel is actually still on the smooth ground, so this part will travel fast. Okay, it's able to travel fast. So what will happen is that the wheel, this part is travel slowly, this part travel fast. You find that what will happen is that it will actually cause a change in the movement or the direction of the ambulance. So you see that this part go fast and yet this part is slow. So slow, this part fast. So what will happen is that if the wheel is still intact, the direction of the ambulance will actually change. This would be the direction of the ambulance. And once both the wheels are actually on the rough ground and both will travel slowly, so it will actually travel in this direction. Okay, so that means that notice that the light ray, or in this case the direction of the van, actually from here it travels, and because it slows down and you find that the direction of the ambulance actually changes. So similarly, you find that if it travels on a rough ground slowly, and when it hits this direction, so again the wheels like this, and this part of the wheel actually is going on a smooth ground, so it was able to travel fast, but this part of the wheel is still slow. So this part of the wheel travels slowly, but this part of the wheel actually travel first. So what will happen is that the wheel will be forced to change, or the ambulance will be forced to change its direction. So you find that this part is slowed down or is being stuck, right? This part move first. So what will happen is that the ambulance will change direction. So this would how the ambulance would turn and would continue to travel, okay, as both the wheels, it goes into the fast path. So right now it is head on. So from fast, okay, head on to slow, okay, you find that the wheels actually when it hits the rough part would actually slow down, but you find that this part, this time round, it will actually slow down uniformly. Okay, this part is slow, this part is slow, so they will still travel in a same manner. So for this situation, if when the ambulance go head on or straight into the rough path, it would just continue to travel in the same direction. But the speed is of course still affected, it travels slowly. So just a quick summary. From the previous example, if the van actually hits the road ground boundary along the normal line, okay, meaning that if it goes in a straight line like this along the normal line, so it would still change its speed, but there will be no change in direction as it's entering at the boundary of 0, so it will still go straight. Okay, if the van actually hits the road ground at an angle, and it will actually change its speed due to change its direction due to a change in speed. So and at an angle means that it's always comparing. If this is 0, this is of a certain angle, maybe 45 degrees and so on. So it hits at an angle, and what will happen is that instead of going straight as originally, it will actually bend in a certain direction, and in this case it will actually what we call bend towards the normal line. Instead of going this way, the light ray actually bends towards the normal line. So in this case, if the speed of the van changes from slow to fast, what will happen that instead of going straight, it because of due to a change in speed, it will bend away from the normal. So instead of going here, it bends away from the normal. Okay, if the speed of the van changes a lot, okay, the change in direction will be more. Okay, what do I mean by that? If let's say instead of a rough ground, it becomes a very muddy ground, so you will expect that the van does not change its direction as usual, but rather it will actually change more. Okay, because the change in speed actually affects the subsequent direction the object travels. Okay, so for the example, even though it's van, light ray actually have the same behavior. So what will happen is that the because due to the greater slowdown in speed, you will actually refract the light or change the direction into a different angle. Instead, you will refract more. Okay, so we'll use a simulation to help you to see. So this is what happens when it is from air to water. So it is fast to slow. So again, it bends towards the normal. But you find that if we change the material from, let's say, water to glass, the direction of the light ray actually differs because it slows the light more. Okay, if you even slow it further, even more, it will change more. But if you slow it less, you find the direction is actually less. Okay, change in direction is less. Okay, and more. Okay, let's just wrap up some of the terms of the refraction. Okay, you'll find that we'll just say that there's this medium 1 and medium 2 where because in order for light refraction to occur, there must be a change in medium. So you find that medium 1 is what we call where the medium where contain the incident ray, and where it strikes the surface and you draw a 90 degrees line, that's called the normal line. Where it is 90 degrees to the surface. Okay, and there's this angle incidence, so you always measure from the normal to the angle incident ray. So in this case, the light ray, the medium 2 will always contain the refracted ray, and this is known as the angle of refraction. So angle of refraction is always from the normal to the angle of incidence. Okay, another concept that I would like to go through is the refractive index. So refractive index of a transparent medium shows how a medium would refract the light. And since the angle of refraction of the light depends on the change in speed or speed of light in the medium, so the refractive index of a medium can also be obtained by comparing the speed of light in the medium with the speed of light in vacuum. So a simple formula, refractive index of a medium is comparing the speed of light in a vacuum versus the speed of light in a medium. So it's actually just a ratio. Okay, example, if the speed of light in vacuum is 3 and the speed of light in glass is 1.97, the refractive index of glass will be 1.25. Similarly, if your speed of light in water is actually slightly faster, 2.25 times 10 to the power 8, so you find that in this case the refractive index is actually smaller. So that's to say that the higher the value of the refractive index, the slower the speed of the medium. So you can say that if you have a high refractive index value, it will affect or you bend the light more. Okay, so and the refractive index will determine how the light ray will be refracted. Some effects of refraction. Okay, because the refraction actually refracts light, so it will actually distort what we see, as you can see from this diagram. So you find that if you have a straw and you dip halfway into water, the straw will appear to be bent. Of course, the straw is not bent, but due to refraction, it distorts the light ray so that we think that the straw is actually bent. So what happens over here? So if you have this straw and you draw the light ray that's coming out, and since it's coming from the water into air, so the light ray will be going from slow to fast. It would refract away from the normal. So this is what happened. You draw a second light ray, same thing, you refract away from the normal. And what you need to do, or if you are seeing over here, what will happen is that you think that the light ray comes from this certain location, and this object A over here, you would think that it will come from here, which is the image. So what will happen is that the straw will appear to be bent to you. Okay, that's all for now.